Hey everybody, this is Andy from VisionScan 3D, and this is part 2 of our 3D scanning workflow series called Digitize. On the right side of the screen, you'll see a 3D representation of the measurement volume of our scanner. The green dots represent the reference point on the component, which are the targets that we've applied in the part prep section of our workflow series. The current screen shows a side view of where the reference points fall in 3D space within the measurement volume. As I turn it to a straight-on angle, we'll take our first scan. In the camera view window, you may see the lines from the structured light of the scanner. Once the scan is complete, the data will plot on the right-hand side in 3D space. Red represents new data. You will also see extra data within the measurement volume in red. We can delete that later. We'll now turn the part and you'll see the measurement volume react accordingly. We'll scan again from a different angle, and when the scan completes, you'll see red again as new data, and the old data is now gray. If I take my cursor and click outside on no elements, it changes all the data to gray. This helps me understand where I need additional data on new scans. We'll continue to scan the part until we've sufficiently characterized the outside. This is where some upfront planning can really save some time. If there are certain characteristics about the part that don't necessarily need to be measured for this project, we don't need to waste time in trying to capture the data in those tight areas. Throughout the project, I will occasionally zoom out to confirm that the part is optimally located within the measurement volume. If the part is not located in the optimal location, you'll see a red square show up. This will indicate I'm either too close or too far. That's when I usually make the adjustments with the scanner and correct it. Now that I've captured the bulk of the data on the outside of the part, I zoom in to find the small areas that are missing data, like this corner. I'll attempt to gather more data, but in this particular project, it's not critical. Now that I've finished scanning one side of the part, I'll flip it over to capture data on the other side. What you see on the screen is green, which represents the backside of actual data. It doesn't necessarily represent a surface. To successfully capture data and align it properly, we need to find 3 reference points after we've flipped it over. Once I have successfully found 3 reference points to stitch the data to the backside, it's much easier to find additional reference points and continue scanning. We will continue to scan this side of the part until we've captured all the data that we need for this project. Now we will go ahead and select all of the data that we don't need and delete it. Here I'll be tracing the component, selecting it, and then inverting the selection to delete it from this angle. I'll continue to delete unnecessary data by rotating the part and exposing it from different angles. Once I have all the unnecessary data cleaned up, it's now time to polygonize the part and finish it. Polygonization is just creating the triangles to actually create the mesh surface of the scan. At this point, all the data is still in point cloud form, with an estimated view of how it would look like polygonized. Now that our mesh is completed, we zoom in just to take a look at the surface finish and some of the features and details. You'll see there's still some remnant data that we'll go ahead and delete right now, but the mesh is complete. Now we can go ahead and export the data as an STL file. Once the data is saved, we are now able to go over to our inspection software and import the file.